And so about the script, like I said yesterday, that we're done with Maki. But I'm not sure whether you can be able to get them today because I haven't seen Mr. Ibas. However, if I can be able to see him, I think we'll send the announcement to the Blackboard on when can you be able to come and collect your script. So we're done. So about the quiz, I'm finalizing it. As soon as I'm done that, I'm going to send the marks on Blackboard, and then we'll see how can you come and collect your script as well. And then, like I said yesterday, that next week on Thursday at 1 o'clock, we're going to give you a third quiz for which we are going to take the best 2. So you must make sure that at least, at most, you have 2 quizzes that can contribute on your module mark. I think we are together on that regard. So, without any waste of time, let me just quickly go to the window journal so that we can start with our lecture. Okay, repeat. While I'm still going there, I think we're there. I think this lecture number what? Lecture number, is it 19? But anyway, it's about repeated systematic.
It's lecture
sampling.
20.
Come again?
I think it's lecture 20.
Oh, lecture 20. Thank you very much. I'm confusing this thing. Lecture 20. Okay, we are done. We're done with the sampling. Sorry. Wait a bit. Okay. Hello, Mr. Rivers. Morning. Morning. How are you? No, I'm in class. Can I tell this? Yeah. Let's say 9:10. Then from there I'll be leaving. So can I tell the students to come to our office? Yes, isn't that you'll come and collect them and then? Okay, you'll come at 10. Oh, so that means I'll wait for you. Okay, so let me just let them know that you will be around. Okay, thanks. Sorry guys for this. I think I was talking to Mr. Ibas. He said it's around, but you'll be here or here around 10. So you can be able to get your script from, let's say, 10. If you have time, you may come and collect your script. Are we together? Hello? Yes, please. If you have time, or by chance you can come this side, please come and collect your script. From 10 o'clock, Mr. Ibas will be here. Thank you very much. Okay, let's continue. We are dealing with the repeated systematic sampling. So here in a repeated systematic sampling, we consider the variation of systematic sampling due to periodic, okay? We sample using systematic, then later we repeat it again. So there are two periods there. So that is why we are saying that we're considering the variation of systematic sampling due to periodic. So now, how do you estimate the population mean during repeated systematic random sampling? So the estimation of population mean, which is mu, under repeated systematic sampling, you use mu hat, which is equal to the summation of yi bar divided by ns. Okay, where ns is the sample size under repeated systematic random sampling. Are we together? And again, if you want to estimate the variance of that estimator, so if you want to estimate, let's say the estimated variance of that estimator we mentioned above, which is mu hat, is given by the var estimate of mu hat, which is equal to n minus n over n.
Sir,
Yes.
the mu hat at the bottom, does it have SY?
The mu hat at the bottom. Which one?
Mu hat, are we estimating for mu hat with a subscript of SY? Or it's just mu hat?
Oh, it's just mu hat. You can just remember for the systematic, it was what? It was mu hat sy, isn't it?
Yes.
And which is the same as y bar sy. So maybe to differentiate with others, you can just say sy. But remember, this is a repeated systematic. So you can just write anything that you can recognize. So let's just put sy, or because it's repeated, let's can I say mu s? Because if you check here, we check this one. There is n for the what? For systematic random sampling. Sample size is n, but for repeated is ns, isn't it? So that you can differentiate these two. Okay. So in this regard, to show that indeed you are estimating the population mean under repeated systematic, that is why we are using mu instead of what? Of mu sy. So that you can have that difference, or instead of what? Y bar sy. So I think here to let's put it in this way so that you won't confuse with that other one of systematic, because this one is a repeated systematic. We are estimating the population mean under repeated systematic. So that is why we're saying mu hat is equal to summation of yi bar divided by ns. That ns again is differentiate the sample size under systematic and repeated systematic random sampling. But the main important thing is the formula. This formula is this one. It's too different to that one for the systematic random sampling. So, but anyway, according to you, you can just use something, maybe if you just want to differentiate in another way. But this is how you write it. knowing very well that we are dealing with what? Repeated systematic random sampling. Any question? Okay. So now, here, to estimate the variance of the estimated population mean under repeated systematic random sampling, we use this formula, isn't it? This is the formula. Where in this case, where sy squared, this is the sample variance under repeated systematic random sampling. Is it S var? Oh, it's sy bar. Sorry, it's supposed to be sy bar, not sy squared. Sy bar. Show that is a repeated one. Sy bar, which is equivalent to what? To the summation of yi bar minus mu hat all squared divided by what? Sample size of the repeated one minus 1. Okay. This is the sample variance under repeated systematic random sampling. Okay. So now, what about if you want to estimate the population total under repeated systematic random sampling? So let's say estimation of population total, which is what? Tau, under repeated systematic random sampling, is given by tau hat. Even here, we're just using tau hat without sy, but we know that is a what? It's a repeated one. So it's n times mu for the repeated systematic random sampling. So what about if you want to estimate the variance of that estimator? So the estimated variance of the population total under repeated systematic random sampling, which is tau hat, okay, it's given by var estimate tau hat, which is equal to the var estimate. But you know that tau hat is equal to what? N times mu hat. So you can substitute then n mu hat. And you know that the estimated var of the population size times the estimated mean is equivalent to n squared estimated var of mu hat. Okay, but we have already calculated the what? The estimated variance of the estimated population mean. Okay, so therefore you substitute, you're going to have n squared n minus n over n sy bar squared over ns. I suppose I'm writing this the right thing. Then from there, the population sizes cancel each other. This one cancel this one. Then you are left with a n open brackets n minus n times the sample variance divided by ns. So this is the estimated variance of the estimated population total under repeated systematic random sampling. I think theoretically this is what I wanted to introduce today, in such a way that later we're going to do some calculations to apply this. So do you have any questions so far? Before we go to example 6 point something. Example 6.6 on page 52 on your lecture notes. Okay, so let's quickly go there and try to apply what we have been introduced here. Sorry for that. Okay, it's example 6 points, I suppose. It's on page 52 in the lecture notes. Okay. For those who are having the lecture notes with them, so please refer to page 52. So in this case, let me just try to just summarize a bit. They said a ferry that carries cars across a bay charges a fee by the carload rather than by a person. So the ferry company wants to estimate the average number of people per car for a month of August. The company knows from last year that 400 cars took the ferry and they want to sample 80 cars. So there you have got the population size, which is n, and the sample size, which is small n. So the population size there is what? It's 400, isn't it? And the sample size is 80 cars. Okay. Now, to facilitate the estimation of variance of the systematic sample, the investigator chooses to use the repeated systematic sampling with 10 samples. Okay, now the sample size changes. 10 samples. N is 10 for of 8 cars. Okay. Use the data given in table 6.1 to estimate the average number of persons. Yes.
The 10, is it NS or just N?
Oh, it's NS. Thank you very much. Sorry. Thank you. It's NS, not N, because it's from the repeated one. Thank you very much for that. Use the data given in table 6.1. Okay, it's a big data, so I won't be able to write it. So please refer. Use table 6.1 to estimate the average number of persons per cars. So in other words, we just want to calculate the what? The estimated population mean under what? Is it under repeated sample? Repeated systematic random sample. Isn't it? So in other words, we just want to find mu, because this is the formula that we use under repeated systematic sample. Okay. It is table 6.1, estimate the average number of persons per car and also provide an estimate of the variance. In other words, in this case, you can just say and find a bound. So in other words, you have to estimate the population mean under repeated systematic random sampling, and then from there you find the estimated var of that estimate. Okay. Of that estimator, and then from there you find a bound, which is equal to 2 times the square root of the estimated var of mu. So this is what we are supposed to do. So let's start now. How do you find the population, estimated population mean? It's unfortunate because this table is too big, but anyway, you know that the estimated population mean under repeated is equal to summation of yi bar over ns, isn't it? If you check that table, the last column for table 6.1 represent the what? The sample means for each elements. So if you can check the last column there, y bar I, which is the mean. So we're going to use that one. Then we sum them up. In other words, you're going to get what? 3 0.75 plus the next one is 3.38 plus there are many. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 of them. Then plus the last one is what? 4.38. Then you sum everything. Then later you divide by the sample size under repeated systematic random sampling, which is what? It's 10 in this regard, isn't it? Then you divide by 10. What is the answer? Oh, those who are having the table, may you please add all the samples, the sample means, sorry. Add everything and then you divide by 10, tell us the answer. Is there anybody who's doing it? Is there anyone who's doing it? Okay, so I'll end up giving you the values, all of them. If you don't have it.
I got 41.63.
41.63 is what? It's a sample
It's
mean.
the summation of the margin for the means.
Yeah, simple mean. It's 41.
4.16,
4.16. Okay.
not 41.
Okay, I get it. 4.16. Then you divide by 10.
No, 4.16 is the answer.
Is the final answer?
Yes.
Are you sure? Okay. What is the final answer? Okay. 4.16 only. It's 2 decimal.
3.
3. Okay, thank you. 4.163, yes, that's true. Then we continue with the what? The estimated variance. So the estimated variance of the estimated population mean under repeated systematic random sampling. So it's n minus n over n. Okay, so you are supposed to have the what? The sample variance. Then divided by ns. So the question is, what is the estimated var of the estimated population mean? But now you have to calculate the sample variance first. You have to calculate the sample variance. Sample variance, which is equal to what? If you still recall the formula, summation of y by I minus what? The estimated mean there. You have already calculated that one. Then divided by ns minus 1. Can you please give the answer for us? This one, simple var. So in other words, simple variance is equal to, we're going to have 3.75 minus 4,163, then you square it, then plus the second one until to the last one, which is what? 4,38, 4,163 squared. Then you divide by what? By 10 minus 1, which is 9. Then give us the answer.
Sir,
Hmm?
would it be okay if we use the rounded value of the estimated population mean?
Yeah, I think it's okay.
Okay.
It's okay. But please round it to 3 decimal places. It's 4.163, not 4.16.
Okay, sir.
Sir,
Yes.
the variance is 0.456.
0.4.
56.
Okay. So now let's go there. Estimated var of the mean. So now, because we have the population size for the systematic random sampling, and we are supposed to have the population size for the repeated systematic random sampling. Because here we are estimating the var of the estimated population mean under repeated systematic random sampling. So I think it's advisable to find what? The population size under repeated. So how do you do that? How do you find that?
Sir, are not we given the population size under systematic?
Oh, they gave us the population size.
Yeah, it's
Under. Let
10.
me check. Not population, not the sample size. Sample size is 10. Population size is what?
Oh,
We don't know this one, but we know this one. Okay.
Isn't it 400?
10.
yeah, they give us 400.
It's 400 is for the systematic. What about for the repeated?
Oh,
So K is equal to N over NS. So is there any, did they give us the interval there? Did they give us the interval? Or the interval, we're still going to use the same interval up there. Did they say something about the interval there? Hey. None, eh?
Yes, none.
None. Okay. So if they didn't give you the interval, you can't be able to find it. But you can find the interval from systematic there. Remember, k equal to, let's start that one before we repeat it. 1 systematic random sampling, in other words, is ns, isn't it? It's equal to, it's going to be what? Population size is 400, isn't it? Okay, then you divide it by what? By 80. So this is what? What is the answer then? Now we just want to find the interval. Remember, we're dealing with the systematic
5.
random
It's
sampling.
5.
We're dealing
Sir.
with the systematic
5.
random sampling. Okay, fine. So now we've
It's
got the
5.
interval. So now we're going to use the same interval. Remember, k equal to n. Now this one is for repeated and ns. Okay. But k, we know that it's 5, but we don't know the what? The population size, isn't it? And we know the sample size for the repeated is 10. Okay. So all in all, the population size under repeated is going to be 50. Okay. So now you got it. So you're going to use this one, 50, population size of 50, to estimate the variance of the estimated population mean. So now let's start. It's what? N S minus N S, you can say divide by NS, then multiply by what? Squared, divide by NS. So which is equal to what? 50 minus 10 divided by what? By 50. And multiply by sample size, sample variance, which is 0.456. Is it 0.5456?
Yes, sir.
Yes.
Okay. Yes. Divide by 10. In my case, I got different answer. My sample variance, I got 0.675. I don't know. What was the problem there? So simplify everything and find the answer.
Zero comma 036.
Okay. So it's 0.036. So that is our what? The estimated VAR of estimated population mean. And remember, we just want to find the bound. Can you find bound for us? Remember, you have to use the whole of that. Because if you can just use it as it is, you might get some errors in that regard.
Our bound is 0.382.
That is our bound. Okay, so now this completes our chapter number 6, which is based on systematic and repeated systematic random sampling. So next time we are going to finalize with chapter 7, and it's not long. It can take us only 2 days to complete that one. I think
Sir.
we can stop here. Any question? Yeah.
Sir,
Yes.
what did you get for your sample variant?
My sample variance, I got 0.675. That's why I'm saying it's different from you. I got.
Sir,
Yes.
just check with your calculator, because here I used the calculator to calculate the variance.
Everybody got the same as what we got. 0.456.
Yeah, I think so, because I used the calculator.
Okay, so it's fine. No, maybe the error is from my side.
Yes, sir.
Okay, so
Thank you, sir.
Thank you very much. We can. I can hear myself. I'm saying thank you very much. We can stop here, and then please, for those who can have a chance, come and collect your